Assalamu alaikum kids, this is Ayaz. I'm going to teach you math for grade 7 and this is going to be week 2 and the topic we are going to cover in this week is other forms of direct proportion, which you can find in your book 2 on page 12. And before I go to today's topic, I think we should recap some of the concepts, because for today's topic, unless you're clear about the direct proportion, the previous topic, it's going to be hard for you to comprehend today's topic. And if you remember, when we say the two or more quantities are having direct proportion, it means that if one of the quantity is increasing, the other will also have to increase, and if one of them is decreasing, the other will have to also decrease, and this increase or decrease must be in a proportion. Or mathematically we can write the same thing. You could see on the screen now that if two variables x and y are directly proportional, then we are going to take two values of each of the variable, and then we can write it down in either of these two equations. You could see there either of these two equations, like the one here. If the first one you could see is basically I took the two values of the variable y, x1, y1 and y2. Same way I took two values of the variable x1 and x2, and you could see you could write it down in this y1 over x1 is equal to y2 over x2, or the same equation could be transformed into x2 over x1, y2 or y1. This is just the mathematically playing with it. And the first equation basically is telling you the two rates are equal. If you remember, in the grade 6 we have studied the rate. Rate is a relationship between two quantities of different kinds. Here y1 and x1, different kinds. But if you just manipulate the same equation, you will come up with the other one also. Simply what you're doing here is the x2, which is in the denominator of the right side, first equation, just bring it up on the left side. It's being divided, it will come up in the numerator. So x2 over x1, y2 over y1. So x2 over x1, y2 over y1 is basically the two ratios. Ratios, you remember, are between two quantities of the same kind, and you could see here. And one more thing we have already studied, that is if the two variables y and x are directly proportional, and if you draw this relationship on the graph paper, you will come up always a straight line, and which must be passing through the origin. So a relationship, directly proportional relationship, will always give you a straight line, and that straight line is passing through the origin. And we will use that litmus test also when we are going to decide the is directly proportional or not. Now let's come up to today's topic. I am taking the two variables x and y, and I'm just as an example taking this relationship, which is, you could see on the screen, y is equal to 3x square. What we are going to see is that whether this y is directly proportional to x in this relationship, or y is directly proportional to x square. Let's see. In the following tables you could see I have 3 rows there, and in the first column I have x, y and y over x. You could see I took the 4 values. You could take any 4 values in fact. So I took 4 values of x, 1, 2, 3 and 4, and just replacing these values of x in the above relationship, I got the corresponding values of y, 3, 12, 27 and 48. I hope you can find it out. Just like just replacing in place of x 1 there, 1 square is 1, 3 multiplied by 1, it will give you 3. Similarly, you replace 2 in place of x, 2 power 2 is 4, 4 3s are 12. Similarly, you got 27, 48. And then in the third row, what we did is we got a ratio y over x. So what you're doing here is taking the y and dividing it by x. 3 divided by 1 is 3. 12 divided by 2 is 6. 27 divided by 3 is 9. Similarly, I got the 12 there. So let's plot the graph between y and x here. You could see in the picture over there, I plotted the 4 points and it is giving me a curve, not a straight line. So I put in the red one over here. Is y directly proportional to x? So if you have clear about the top of last week's stuff, you should say no here. And here I have another table now. What I'm doing here is I have 4 rows here. So in this table again I took x, took 4 values of x. Let's say I say any 4 values you could take. So 1 2 3 4 I took it. So in the second row I have the x square. So what I'm doing here is I'm squaring the value of x here. So 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16 here. And the third row is y, which is the same in the previous table, what we have over there, 3, 12, 27 and 48 over there. And in the fourth one, now I have the ratio between y and x square, not y over x in the previous table, if you remember. So here what I'm doing here is I am dividing y by x square, not by x. 3 divided by 1 is 3, 12 divided by 4 is 3, 27 divided by 9 is 3, and the last one also gives you 3 here. So now let's plot the graph between y and x square, not y and x like the previous one. So here you plot, you could see the 3 red crosses over there, the 3 points. I just plotted the 3 points here, the first 3, 1, 1, 2 and 3. So you could see if you join these 3 points, it's going to give you a straight line. So again I put it here, that is y directly proportional to x square. Now you should right away jump on this one, that what should be the answer here. So here let's make a conclusion here. So this relationship y is equal to 3x square, here in this relationship y is not directly proportional to x. Why? Because if you want to play mathematically with it, you could see in the second line what I did is y is equal to 3x. I just split it, the x square into x, 3x multiplied by x. Okay, and then what it did is the single x I brought it on the left side. It was multiplied. When you change the side, it comes down here in the division, in the denominator. So y over x is equal to 3x, and 3x is not a constant. You know how? I can show you here on the screen. See, let's take any value of x here, 5. So just replace 5 in x. So y over x, I put the x5 there, is equal to 3 into x, which is 15. Now let's take another value of x here, let's say 8. So I replaces x by 8 here. So you could see it is giving you 24 now. So every time you are going to change the value of x, you are going to get a different y over x. So what does it mean? The ratio y over x is not constant. For directly proportional, y over x must be constant, right? Okay, so but in fact here y is directly proportional to x square, and I can show you here too. Simply in the above relationship, bring that x square down here. You could see in the bottom of the screen now, y over x square is equal to 3. I brought the whole x square down, which is being multiplied, comes on the other side, gets divided there, and is equal to 3. And everybody knows 3 is a constant. So what we can say, we can say that y is directly proportional to x square and is not directly proportional to x. Look at the bottom with the blue color. That's the result here. And we have seen already in the graph 1, which was drawn between y and x, it gives us a curve, not a straight line. While the graph 2, which was drawn between y and x square, it gave us a straight line which was passing through the origin. Okay, guess ready, champ. Now it's your turn. Let's see how much you got, and how I'm gonna judge this one is, what you are going to do is just take a short break here, means just pause your video here and go to your book 2, page number 15 and example number 5. Just go through each step of the example number 5, and then when you are done with it, then start your video again to me, and I hope it will give you, as I said when the screen is writing over here, that it will give you a little flavor that I'm going to do now. Okay, here I'm helping you with the practice now 5, which is on page 15 of your book 2. This practice now is basically what is asking us is that there are 2 parts over there, and in each part what we have to state is that which 2 variables are directly proportional, and we have to explain it also. So the first one you could see is y is equal to 6x square. What he is asking us is that whether y is directly proportional to x square or y is directly proportional to x. Same way in the second part, we have to state is y directly proportional to x, or under root y is directly proportional to x cubed. Okay, let's see the solution in front of you now. So look at the first one. Mathematically what we did here is, in the second line you could see I brought the x square whole of it on the left side, which was divided on the, it was multiplied on the right side, comes down here, and as you see y over x square is equal to 6 now, and 6 is constant. So this ratio y over x square is equal to constant. So what does it mean? Means y is directly proportional to x square. And look at the second part now. The second part, what I did is that x cube, and you guys knows the coefficient of x cube is 1. 1 is always already there. So 1 is multiplied with x cube there. So I just brought the x cube on the left side in the denominator now, and 1 is remaining on the right side. So you could see the ratio under root y over x cube is equal to 1, and 1 is constant. So we can say under root y is directly proportional to x cube. Okay, now here is your first assignment, your exercise 1b, the question number 4, all the 4 parts A, B, C, D. You gotta do those parts, and remember all these four parts are exactly the same as we have done the practice now 5 and the worked example 5. And also remember, in that question he's asking you to explain your answer, not only the two variables, which two variables are directly proportional, but you gotta tell the. So I'm going to wait for your homework back to recheck and see how much you got. So that's it for today's lecture. Goodbye, take care, thank you, bye bye.